Alright, welcome to 5.3 part 1. This is going to be likely a 3 or 4 part section before we go on to the next one. So today we're talking about trig functions, kind of a little bit different than 5.2 was, okay, but still the same trig function, those same 6, okay? So the essential question is, how do I find angle measure using the right triangle based definitions, okay? So the right triangle based definitions, looking at this, we have the x, y, and the r from the previous sections, but here we have in this figure the side y, that's going to be called the side opposite to, okay? The side opposite of angle A. Again, we're looking at angle A here, okay? Let's do this, you can see it. The side x is going to be called the side adjacent. Remember, adjacent means next to. So if you look, x, it's right next to angle A, and so it's going to be adjacent. And y is going to be across from, in geometry I teach my kids, a straight little arrow that'll put it opposite to, okay? And then r, of course, is the hypotenuse. And so if we were looking at this as a right triangle, we have an opposite side of A, an adjacent side, and then a hypotenuse, okay? Things that you learned in geometry class. So, going from this, looking at a general form of a triangle, if A is any angle that is acute in standard position, then we have our old definitions, like sine of A is y over r, but we're also going to view it as opposite of A over the hypotenuse. Cosine is going to be adjacent of A over the hypotenuse. And tangent is going to be, y in this case is going to be opposite of A over adjacent of A. Okay. Now you memorized this in 10th grade, right? You learned SOHCAHTOA on the side here, where sine is opposite of hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. That's something that you memorized, okay? Now for the other three, remember that they are the reciprocal functions of the first three. So cosecant goes with sine, so it's just going to be this one flipped. It's going to be the hypotenuse over the opposite of A. Secant's cosine flipped, so we have the hypotenuse over the adjacent of A. And cotangent is tangent flipped, so we get adjacent of A over opposite of A. Okay? So just another way to look at this, nothing crazy. So, based on this, we're going to find the sine, cosine, and tangent values for the angles A and B in the figure. So nothing too crazy. We're not looking for A and B. This is a little confusion from when you were in geometry. So, sine of A, well, that's opposite over hypotenuse, right? Based on this. So opposite of A is 36, hypotenuse is 85. Remember, the hypotenuse is always across from the right angle, okay? For the cosine of A, it's going to be adjacent, 77, over hypotenuse, 85. Make sure you reduce these if you can. And the tangent of A is going to be opposite, which is 36, over adjacent, which is 77. Okay? Just going based on that. Now that was working from angle A. Now we're going to work from angle B. What if I have another color? Hold on. I have a green. Okay. So going from B now, we have the sine of B. So now opposite of B is 77. So we have 77 over 85. Cosine of B is going to be 36 over 85. And the tangent of B is going to be 77 over 36. Okay? Now take a look at this. Notice how the sine of A and the cosine of B are the exact same. Okay? There's going to be a name for those. Okay, and that's what we're going on to next. That's the whole point of this was. So, next we get cofunctions. Okay, cofunctions. So like we just said, the sine of A, right? Oh, don't need that. The sine of A is A over C, right? But that's the same thing as the cosine of B, because the cosine of B is A over C. Okay, so think back to that chart from the last page. Notice that we can use those a bunch here. So for example, A over B for A over B, that's tangent. Okay, so the tangent of A is A over B. That's the same thing as the cotangent of B. The cotangent of B is going to be the adjacent side over the opposite side of B. Okay? And then, the last one, C over B, that's going to be what relationship for A? So C is the hypotenuse over adjacent. Hypotenuse over adjacent is the secant of A. That's going to be the same thing as C over B for B. That's going to be the hypotenuse over the opposite side, which is going to be the cosecant. Okay? So here we get some what they're called cofunctions. Basically a little chart, but what we get here is that the sine of A is the cosine of 90 minus A. Okay, these are identities. And so basically what you're going to have here, I'm trying to find this little chart. The little chart they give you in the notes, which is super, super handy, is this. They have the example where they have the cosine of 52 equals the sine of 90 minus 52, which is the sine of 38, is that the number? 38. That's the reason I'm writing this down for you. These are all useful, right? Just like up here, this A, sine of A, and the cosine of B matched. Okay? Now, that's what we're going to get from all of these. The sine of A and cosine of this. But the important part is that right here, these are your cofunctions, the sine and cosine. They're called cofunctions. And these two numbers right here, 52 and 38, they're going to be complements. Okay? Let me put a little arrow. Notice how 38 and 52 make 90, right? So that's what we're going to get from this. So we're going to use these charts to try to do that. Okay? So here's the one for sine and cosine, secant and cosecant, tangent and cotangent. We have a bunch of them. Okay? So we can go ahead and use this chart a lot here. So the sine of 9. Now we want to write a cofunction version of this in terms of its cofunction. So the cofunction for sine is cosine. So we're going to go ahead and make this equal to sine of 9, so 9 is our A here, cosine of 90 minus 9, which is cosine of 81. Okay. For cotangent, now we're over here. The cofunction is tangent. So the cotangent of 76 is the tangent of 90 minus 76, which is tangent of 14. I'll put a parenthesis here for no reason, in case I'm mistaken. Okay. And for cosecant, we're right here, of 45, that's the secant of 90 minus 45, which is the secant of 45 degrees. Okay, so there's not too terribly much to that. All right. Okay, on to the last thing from this first part of the section. We're looking at special triangles. Okay, and so we're going to use these a ton in trig, and this is something that you learned in geometry again, special right triangles. And there's two different triangles here. We have 30, 60, 90 triangles. And then we have 45, 45, 90 triangles. And so we have this first one here. And so this is, in general, a 30, 60, 90 triangle, but we're just choosing the hypotenuse to be 2 because it turns out to be really nice. Okay? So what you can do from here is you can do all kinds of stuff with trig, and that's super useful. For example, you can find all the sine, cosine, tangents, and whatnot of this figure right here. Okay? So in geometry, you learn that all special right triangles, and you write in all triangles in general, if they're 30, 60, 90s and they get bigger or smaller, they are all in proportion to one another, right? So if I want to work with it, you might have learned t, 2t, t squared to 3, something like that. So we'll be using that quite a bit, okay? So from here, we also have the 45, 45, 90. I'm going to draw that for you. So I'll label this as 45, 45, and 90. I want to make sure I match the book here. So what they have going on is they have a 1 here. So there's a 1 and a 1. Remember, this is an isosceles triangle, so these two need to match. And if these are both 1 by the Pythagorean theorem, right, we do a squared plus b squared is c squared. So we have 1 squared plus 1 squared is c squared. That's 2 equals c squared, so c is root 2. So that right there is root 2. Okay? So now if we ever encounter a 45, 45, 90 or a 30, 60, 90, we can draw those in general and then manipulate that pattern to match that in general. Okay? So you have a few options. You know, when you choose this as 2, you can find the rest of them pretty easily, but we'll go from here. So now it's going to be pretty simple. We're going to use these as a kind of a trick, if you will. But for example, the sine of 30, find the special right triangle, 30 up here. Sine is opposite of our hypotenuse from the previous page, so 1 over 2. Cosine of 30, adjacent, root 3 over 2. We're going to do this for all of them. Tangent is 1 over root 3. Now, there's a tricky spot, right? Something that you learned. You cannot have a radical on the bottom. So to rationalize that, we need to multiply by root 3 over root 3. And we're going to get radical 3 over 3. That's the accepted term. Okay? For the cotangent, it's just this flipped, so it's going to be just root 3. I just flipped this first part right here, right? For the secant, if you want to look back and not do it that way, secant is hypotenuse over adjacent, so for the secant of 30, it's going to be 2 over root 3. So 2 over root 3, again, it's just flipping this one. Rationalize it, root 3 over root 3, and so we get 2 radical 3 over 3. And for the cosecant, that's going to be the flip of the sign, so it's just going to be 2. Or if you look at it like this, it's going to be 2 over 1. Okay? So that's kind of the setup for that. Make sure you rationalize the denominators, but other than that, I'm just looking at this picture and going from there. Now, if you can imagine, right, it wasn't, say the hypotenuse wasn't 2 or it wasn't root 2, we would just take every side times that, and we'd end up getting the same fractions at the end of the day, right? They'd simplify the same. Okay? So for 45, the sine, I'm going to choose this one to work off of. It's the same thing. But the sine is 1 over root 2. When rationalized, you get root 2 over 2. That's your final answer there. The cosine is the same thing, the same exact steps. And the tangent is just 1. Okay? Now when you flip it, for the cotangent, that's this flipped is 1. For the secant, we end up getting the secant is the opposite of cosine, or flipping it, so we get just root 2 and root 2 again. If you can imagine, secant is hypotenuse over adjacent, right? So we get hypotenuse is root 2 over 1. Okay? Or flipping this first step right here. And lastly, we have 60. The sine of 60, back to the top one. Sine is root 3 over 2. Cosine is 1 over 2. And tangent is root 3 over 1. Okay? Now the cotangent, flipping it, is 1 over root 3, which is going to be root 3 over 3 when rationalized. The secant is going to be flipping the cosine, so it's going to be 2. And the cosecant, flipping that, is 2 over root 3, which is going to be 2 root 3 over 3. So you're going to see a lot of repeats that kind of bounce around a little bit. Okay? But that is going to be that chart that we're going to use a lot. And eventually you're going to have these all memorized. You're going to have all the sine and cosines of these things memorized. And once you have sine and cosine, right, they're all good. So this is something you're going to need to be able to do. Okay? And once you have these triangles, right, it's really not too bad. And this is something you might still have memorized from when you were in geometry. So that's good to know. Okay? And that is the end of the first video. There will be at least 3. So thank you for watching. Good luck in the next one.